Welcome back. Today we're going to talk about special types of right triangles. This is also something that we aren't necessarily having our first go around with. And so when we talk about special right triangles, we have two types of special right triangles. The first type is the 30, 60, 90. Because it's a right triangle, we're going to go ahead and put this right angle down here. And the way that this basically looks is we have two other angles, right? And they're going to be in this configuration. Notice still all of the angles add up to 180. This is not really a surprise. And kind of the way it looks is basically we want to base everything off the smallest unit of measure. And the smallest leg is going to be the leg that's opposite of the 30-degree angle. The reason this is because it's the smallest angle, and so that's going to be our smallest unit of measurement. Everything else is going to be based off of that. What does it look like? Well, it's pretty simple. The hypotenuse is going to be 2 times whatever that short leg is. And the long leg, which is the leg opposite the 60, is going to be square root of 3 times that short leg. Everything is based on the short leg. And so it really is a configuration of saying as soon as you find the short leg, you can find everything else. I remember it as I have the 3 here, and that kind of goes with this square root of 3 here. So to review, the hypotenuse is equal to 2 times the short leg and the long leg is equal to square root of 3 times the short leg. Alright, let's look at this. Find the lengths of the legs if the short leg is 5 in this 30, 60, 90 degree right triangle. If I look at this, I'll just label it 30, 60, 90, and my short leg is going to be 5, and I know that it's the short leg because it's opposite to 30. And basically I remember that this is 2 times short leg. And this is square root of 3 times short leg, right? And so when I go through and I look at this, this is going to be 2 times 5, which is equal to 10. And this is going to be 5 times the square root of 3. I can leave it like that. That's all you really need to do. Another example. I would like for you to try this one on your own. Draw a picture and then figure out what exactly is going on here. We will talk about it in class. All right? Next type of right triangle. The second type of special right triangle is a 45, 45, 90. Typically, we orient it like this with a 90-degree angle up. What that means for us is each of these base angles is 45 degrees. How does this affect what we're doing? We now have an isosceles triangle, and if you remember anything about an isosceles triangle, the congruent legs are opposite the base angles. Well, that means that both of these are the same length, and we'll call them x length. They're both the same length. This is good for us because if you have one, you can have the other. So the legs are equal to x, and the hypotenuse is going to be x times the square root of 2. Or square root of 2 times the leg. That's all there is to it. So you find the leg length, multiply it by the square root of 2, and you can even just leave that as a reduced radical. An example. If I've got a tent here, and the top of the tent pole to the ground is going to be this distance here. I could have picked any color, but I picked that one. Let's look at blue. It connects here, and when we put it to the side, it kind of looks like this. And this is the rope. So this is going to be our 45, 45, 90. And this is a 10-foot rope. Well, in this case, we know that we have the hypotenuse. Well, that could be a problem because I don't know what the formula for the leg is, but I know that the hypotenuse is equal to square root of 2 times the leg. Well, let's substitute in what we know. We know that the hypotenuse is 10, so 10 equals square root of 2 times the leg. And if I want to find the leg height, or which is the height of the pole, I can say, well, I'll just divide by the square root of 2. And previous math teachers would have a problem with this, but for this class, it's okay to leave it like that. So we could say 10 square root of 2, 10 over the square root of 2. Let me erase this so that there's no confusion. 10 over the square root of 2 is equal to the leg. So you could go ahead and put that in a decimal form if you would like. But that's basically how special right triangles work. So know those relationships between those legs, and we'll see you next time.